Hi, everybody. All right. So our topic for today is transformations inside P5.js, right? So we're primarily going to be talking about rotation. I think that's the most interesting one, but we're also going to touch a little bit on translation, right? So we'll deal with what those things are, how they work, and basically we're going to have to start looking at sort of the fundamentals of how the graphical systems approach transformations in general, right? So I'm gonna try and draw some examples for you, and hopefully we'll tackle this topic together. So I think in order to illustrate this, we are gonna start by drawing a grid, right? So we are already used to doing this, and we've done this before. So let's try and use one of our methods that we've used before in order to just draw a grid on the screen, and then we can see how we can rotate that grid, or how we can move it around, and so on and so forth, right? So we're gonna have a grid with cells of 100 pixels wide and 100 pixels tall, right? So let's formalize this into a variable. So let's say cell width is 100 and let cell height also be 100. Okay, so we're starting there, and then we are going to um, um, have a background, right? So we don't have to do much besides that in the setup, but we're going to have a background, and we are going to start drawing out grid. So we're going to say for um, let x, we're going to use x and y. Since this is going to be horizontals and vertical, let x be 0. So we're going to start at 0. And then x is going to go as far as and up to and including width divided by cell width, right? So if our width is, let's make it a little larger. Let's make it 800 by 600, our more or less common size, right? So if our width is 800 divided by 100, it's going to be 8. So we're going to have 8 columns. And so I also want to draw a line at the end, so we're not making 7 because it's below 8, right? So that's why I'm adding less or equal to. So not just less than 8, but equal. So including 8. And then, so I'm going to do it 9 times, right? From 0 to including 8. And then I'm going to, every time, I'm just going to move x to the next, right? So x plus plus. So it's going to start 1. It's going to start at 0, and then 1, and then 2, and then 3, and then so on and so on and so on until we reach 8, including 8, right? So, okay, so that should be all more or less familiar by now. So, and then in between the curly brackets, and by the way, you will notice me kind of doing two styles by default. I think the curly bracket is opened right next to the closing parenthesis. I sometimes put it on the next line. It's just a formal concern. I think some languages have more preference towards one option versus the other. I think JavaScript classically tends to do it this way. And then something like C Sharp, which we use, for example, in Unity or in other programming environments, um, tends to do it this way. It fundamentally doesn't matter, right? So, okay, so just this aside being done, we're gonna draw a line, right? So for every one of our x's, 0, 1, 2, 3, we're gonna draw a line. So line, and that's gonna go between x value and then 0 on the y-axis, and then x value and full height on the y-axis, right? So wherever we are, we're gonna go from x 0, x height. But wait a second, didn't we say that we're going to do it 8 times? So if we're going to start with x, we're going to draw it on pixel 1, right? Just to kind of demonstrate what it would look like. So let's head over here, and let's have our, that's going to be our sketch, right? So I'm going to start with x being 0, so right here, and then x plus plus, right? Notice we have x plus plus over there. X plus plus will mean plus 1. So 0 plus 1 is going to be 1. So it's going to be right next to it. And then it's going to be another one right next to it. And so I'm going to draw 8 lines right next to each other. So instead, I need to separate those lines by the width of my cell, so that the first X is going to be here, and then it's going to go to the next one, but it's going to include the width of the entire cell, and then again, right? And so on until we reach this point. So in order to do this, I just need to multiply it by my cell width. So when it's 0, it's going to be 0. When the X is 1, it's going to be the full cell width. When X is 2, it's going to be 2. So it's going to start drawing right here, and so on. Okay, so all right, so let's do it this way. So we're going to X times cell width, and then X times cell width. All right, so quick check just to make sure that we're not completely off. All right, looks good. So we have a line here, and so on, and then we have a line at the very end. And then we need to do the same thing for the Y, and they don't need to be nested because I'm not trying to address every single cell, right? I just need to draw some lines so I can have them on the same level. So I'm going to say let Y equal 0 for as long as Y is less or, again, equal to height divided by cell H. And in our case, it's going to be 6, right? I'm going to do Y plus plus. So let's do it again. And then we're going to draw a line again. So line. And then we're going to have this time 0 is going to be for the X. And then the Y value is going to be for the Y, obviously, right? And again, we're going to need to jump by the whole size of the cell. So I'm going to have to multiply my Y by cell H, and then it's going to be width, and then Y times cell H. Okay, all right, so now we have a grid of squares. Fantastic. Right, so, and I can, for example, give it a color. So let's do stroke, and then 255, 0, 0, and then to make it red, give it a stroke weight of, let's say 3, right? So each line is 3 pixels wide. Okay, perfect. So we have a grid. So now we kind of have this idea of how the space is sectioned off, right? So we have each line marking off 100 pixels, 100 pixels, 100 pixels. So if we go into our examples, and you'll see like the rotate options, or even just going to the reference, right? Let's open reference and go to like, how do I rotate something? Rotate. Okay, so it rotates the coordinate system. And that is a very important thing, and that is why we started by drawing a grid. It doesn't rotate a shape. It doesn't rotate an object on the screen. It rotates the entire coordinate system, right? So if you look at the syntax, it takes the angle, and then you can also provide it with the axis around which you want to rotate, right? Typically, it rotates kind of like this, right? So technically along the z-axis, but you don't really think about this. But also notice that if we were to rotate it, we would have to rotate it. And if we provide the axis, we would start having to rotate it in 3D, which is not what we're doing, right? We are working in 2-dimensional space, so we're just going to provide it with the angle, okay? So, and the angle of rotation is specified in angle mode. So that is another important thing, right? So if we go to, oh, it doesn't take me to the angle mode. Okay, let's do a search for angle mode. Yay, angle mode. All right, so angle mode is a system used to measure angles. Degrees and radians are both units for measuring angles. There are 360 degrees in one rotation, or 2 times pi, about 6.28, right? So if pi is about 3.14, so it's 6.28 radians. So You might remember radians, you might not, but to just kind of go back to this idea of what radians are very useful. They're way more useful than degrees. Most mathematicians and geometers use radians because radians actually reflect the fundamental relationship between the radius of the circle and its circumference. So if you remember the formula for the circumference of the circle, I have a way to quickly remind you, right? Circumference of a circle formula. Very simple. It's 2 pi r, right? So what that means is that the length of the circumference of the circle will be twice the radius times pi, or 2 pi times the radius. Doesn't matter which way you multiply it at all, it's just multiplying it, right? So here's what it means fundamentally, right? So let's kind of like erase, or actually just move away from this, right? And if we were to draw a circle, let's draw a circle, right? So here's our, it was not a very good way of drawing circle. Let's actually draw a circle, maybe like right here, right? So here's our circle, right? So we have a center in this circle somewhere here, and we have a radius. So if we take the length of this radius, right? Whatever that length might be, sometimes we talk about unit circle, which means that it's just 1 unit of length. 1 meter or 1 foot or whatever other unit of length you're using. And then we're going to start kind of like applying the length of this radius around the circumference. So it's going to be something like 1, right? Somewhere here, you're going to get 2, right? If you go a little further, like here, you're going to get 3. So like a full rotation, right? Or sorry, half a rotation will be 3.14, something like this, right? And then you can get to about 4 over here, 5 will be over here, and then 6 will be over here, and then full rotation will be 6.28, or 2 pi, right? So here's pi, here is 2 pi. And so this is what the circumference formula simply means, is that the circumference of the circle is 2 pi of the radius. And then if we have twice the unit, right? Like if we take this as 2 meters, for example, the radius is 2 meters, right? So we just, this number 2 pi or 6.28 is going to be doubled, and so on and so forth. So there's this fundamental relationship between the length of the circumference and the size of the radius, right? The radius grows, the circumference necessarily grows, right? And so these numbers, 1, 2, 3, 4, 5, 6, and so on, those are radians, right? So 1 radian, 2 radians, 3 radians, and so on. So this angle is measured as an angle of 1 radian. So it kind of makes a lot more sense than just some weird arbitrary division into 360, which I think you might know, or you might not. We inherited from ancient Babylon and their obsession with number 60 in general. They had like a 60-based numbering system, and this is where we kind of inherit the 60 seconds in a minute and 60 minutes in an hour, and so on and so forth. And 360 was the number of degrees in a circle, and it also like the number of days roughly in a year. And they had like this weird festival for the extra few days left over. But okay, so we figured out what radians are, and so we are going to be using radians for our rotation because this is the default system, right? So okay, so let's go back to our rotation, right? So we talked about the fact that we can run rotate as a function as long as we provide the angle of rotation. So if we say angle of rotation is 3.14, it's going to be rotated 180 degrees, right? Half a circle, half a full rotation. right? And then if we say it's like somewhere maybe around here, right? It's going to be quarter of a rotation, right? And so somewhere around here is kind of, it's 1 point something something. But in reality, like 1.57. But in reality, it's a lot easier to just say half of pi, right? Because quarter of 2 pi is going to be half of 1 pi. And so these are the numbers that we use very often in conjunction to rotation. So if you want to do a quarter or like 1/8 of a full circle rotation, you would say it's a quarter of a pi, right? So you just start expressing how much you want to rotate in the values of pi. Okay. So let's go back to our code and let's try to rotate our grid, right? So let's do rotate, and we'll rotate by, what did I say, quarter pi, right? And actually, so I didn't type it correctly. So if you type it like this in all capitals, you'll see it goes pink, right? So it's one of those numbers that's already provided for you. Just like width is just inherits from this number, and height will inherit from this number. Quarter pi will already be like a number that exists in the system, and it will give you a certain amount of rotation, right? So if you run it like this, let's see what happens. Okay, so our grid rotated, and the important thing is what it rotated around. And so it rotated around the 0, 0 point, right? That's a very, very important concept. So we are always going to be rotated, we're always going to be rotating things around the 0, 0 point. And so if we want to rotate something else somewhere else on our canvas, we kind of have to topple everything and put the whole system on its head and move the 0, 0 point. So move the entire system of coordinates in order to rotate something around a certain point. Okay, so let's try and illustrate this. But and so I'm gonna try and draw 2 grids. But instead of repeating myself and rerunning all these lines again, in order to draw 2 grids, I'm going to try to be a little bit more economical with code, and I'm going to introduce a new function into my code. So a new function is going to do a certain collection of actions, right? That's what functions do fundamentally. Like, this is kind of my definition of what functions are, but functions are collections of actions that you can group together and you can give them a certain name, right? So we already do this in real life, right? So if you think about this, we have a function for ourselves called brushing teeth. And brushing teeth involves actually like a whole bunch of actions. You have to like pull out your toothbrush, and you have to pull out a toothpaste and open up the toothpaste and squeeze some toothpaste onto the toothbrush, and you have to wet it, and you have to put it in your mouth, and you have to move it this way, and you have to move it that way, certain number of repetitions for 2 minutes or more, and so on and so forth, right? So like it's a collection of actions, but we call it one single name, brushing teeth. And so if you want to ask somebody to go brush their teeth, you don't have to explain to them over and over and over again what are the steps. You teach that person, or hopefully they've been taught maybe by somebody else, how to brush their teeth, and you go and tell them, go brush your teeth. So this is fundamentally what a function is, right? This is kind of like the way I would explain it. So if I wanted to keep repeatedly drawing different grids, I can just encapsulate this collection of actions of drawing a grid into a function. Let's do it like this: function draw grid, right? And specify what actions constitute drawing a grid, right? So let's say like everything here, from setting the stroke to setting stroke color, stroke weight, and then repeatedly running the lines for the columns and lines for the rows, right? That means that would produce a grid for us. So I'm going to take all of that and paste this in here. And that's going to draw a grid for me, right? So now if I just say, hey, I already specified this collection of actions under the name draw grid. So if I ask to draw a grid like this, you should just do everything that's specified between lines 16 and 27, right? So if I run it like that, it's just going to do the same thing for me. But now I can ask it to draw a grid several times under different circumstances, right? In fact, I can even provide certain ways to modify that grid based on what I need. So for example, I might want to draw it in different stroke weights and in different colors, right? And so in order to facilitate this, I would have to rewrite the function every time if I want it. Like I would have to draw red grid and then with stroke 3, and then draw green grid with stroke 2. Or I can just keep it generic and then provide some additional information on how exactly I want it done, right? So if I want to ask somebody to brush their teeth with Colgate, I would tell them like, here's the toothpaste Colgate, go brush your teeth with that toothpaste and not any other one, right? So in order to do this, I need to supply arguments into my function. It's a technical term. So I like to name my arguments with an underscore just so that I know what this thing is and where it's coming from. And so I'm going to say color is going to be one of the arguments. So I'm going to say underscore color, and then I can give it a default value. So I can say, if I don't specify explicitly what the color is, just use a default value, and that's going to be just black, right? So 0, 0, 0, right? So that's going to be the default for my color, and then I'm going to also provide a weight. So weight, and the default is going to be 1. So now, instead of saying, oh, draw it with the stroke of 25500, I'm going to say draw it with color, whatever color I'm supplying. And if I'm not supplying it, then you're going to be using the default value, right? And draw it with weight. So like this, right? And again, whatever value I'm supplying, or if I'm not supplying anything, weight of 1, right? So if I run it like this, it's going to draw it in black with a stroke weight of 1 because I didn't supply anything specifically. But if I say color 25500, and then after the color, I'm going to set the stroke weight of 3, we're going to go back to red grid of 3 pixels wide. So the position of your value is what determines how it's applied. So the very first value is going to be applied to the first argument, and the second value is going to be applied to the second argument, right? So if I switch them around, I'm probably going to get an error or some kind of like a weird result, or it might just revert to defaults, depending on how P5.js. I don't think I've ever tried it. We can see what happens if I say 3 and then color. It just reverts back, and then so stroke weight was expected a number but received an object which specifies the color. So like, I don't know what you're doing, I'm just going to use defaults, right? So it's the position, right? So the first value versus the second value that will specify how that value is going to be applied, right? Whether it's going to be applied to be the color or it's going to be applied to be the weight. All right, so now we know how to make functions, right? So now we can draw 2 grids. So let's say I have 1 grid rotated by quarter pi, or let's do like even smaller values, right? Oh, another thing that you can do is rotate by like really tiny amounts, right? Something like 0.1, right? Since we know that the full circumference is 6.28, something like this will just give me like a very small angle of rotation, right? And then I'm going to draw another grid, and I'm going to rotate that one too, right? So I'm going to say, and notice how like we have to first rotate and then draw. That should also be a hint that we're kind of moving the entire coordinate system and then start applying our shapes onto it, but we do have to do that. So let's say rotate, and then let's do 0.2, right? Just a little bit different. And then draw grid. And then we are going to give it a color. And this time, let's give it a color green. So 0 to 55, 0. And let's give it a stroke of, stroke can be, again, 3. Doesn't matter, right? So if we run it like that, you will notice that they were both moved by a slightly by a slightly different amount. But so instead of, it was kind of like the 2 degrees were applied not from the top, but the 2 degrees were applied from the red grid. So it rotated once, drew the red grid, and then rotated again and drew the green grid, right? So this is not the same amount. So the 0.2 is larger by 0.1 radian, right? So like you can see that this is a 0.1 radian over here, and then between the red and the green is 0.2. So 0.2 started calculating from the position of the red grid, right? So that's an important concept, that if we're going to stack transformations, we are going to stack them on top of one another. And so if you want to avoid stacking them, if you want, for example, if you want the green grid to be rotated by twice the amount from the than your red, right? Because right now it's 3 times the amount. So 0.1 over here plus 0.2 over here. You would need to literally take the entire system of coordinates called a matrix. So you need to take this matrix and you need to save it in memory, do your thing, and then remove it from the memory, right? So that operation is called pushing the matrix into the memory and popping the matrix from the memory, right? So we are going to apply push function before we rotate and draw, and then we're going to apply the pop function after we do the rotate, after we're finished with it, but before we proceed to the next transformation, right? So here we go. So now the green one is moved by twice the angle, right? This is closer to what we expect. Well, actually, that's exactly what we would maybe normally expect, right? So I think another way of demonstrating what that means is if I push the let's just remove this push and pop, right? I'm gonna comment this out, and I'm gonna show you translate function. So translate function moves something, right? So if I wanted to rotate around, let's say, the center of the screen, I would have to move my 0, point, because we're always rotating around the 0, point, to the center of the screen, right? So let's just look at how translate works. So if I'm going to move translate to, well, let's say, just so that we can see it a little bit better, let's do 1/3, right? So width times 0.33 and height times 0.33, right? So it's 1/3. And then if I wanted to translate width times 0.33 and height times 0.33, right? So if I don't apply the push and pop, if I don't push the matrix into the memory stack and then pop it from it, right, so that it's no longer, it evaporates, it doesn't exist anymore, here's what's going to happen. Those transformations are going to be stacked, right? So I moved it by 1/3 and 1/3. And so now my 0, point is here. And then I moved it by 1/3 again. So now my 0, point is here, right? And so again, I'm rotating it by 0.1 radian, over here and by 0.2 radians over here. But again, all the transformations are stacked. And actually, so I'm not rotating it by just by 0.2, I'm rotating it by 0.3 because it applies this rotation first and then this rotation. So both the translate function and the rotate functions are stacked. We, instead of translating it by 1/3, we stacked it, and so translated it twice, and we rotated it twice because those stack up. And that can be useful if, for example, if you're trying to emulate a system where like one object rotates and another object rotates around it. Like think about a planet with a moon, right? That could be very useful. But in most cases, we do want to just apply certain transformations to those separate entities, right? So what we would typically do, we would apply the push, and we would apply the pop, right? And so this way, now they're translated to the same point. Well, that's not kind of what I wanted. So let's just remove this translate. We're going to leave the red grid at the 0, 0 point, and let's apply the transformation to half the width and half the height, so the center of our little sketch. And then here we go. So we are now rotating this by 0.1, right? And then so I pushed the matrix, rotated it by 0.1, drew the grid, and then I popped the matrix from the memory. So I save that stack, my temporary stack. You can think about maybe like a layer in Photoshop, except you have to destroy that layer and then the graphics just remain. But fundamentally, you're operating in a different memory stack. So you push the matrix into that stack, rotate it by 0.1, draw the grid, then pop it out. That stays on the screen. Then we move on. We translate to the center of the screen from the 0, 0 point. And the 0, 0 point was reinstated over here necessarily by the pop function, right? Pop always brings your 0, 0 point back to the top left corner, right? So we're going to translate to the center and then rotate by 0.2. And you can see how that rotation applies. For example, if I do quarter, let's do quarter pi over here, and then another quarter pi, right? So typically those two would stack. So my green grid would be 90 degrees, right? Or like half a pi. But in this case, since I'm pushing and popping the matrix, oh wait, I translated by quarter pi. I didn't rotate by quarter pi. I wanted to do it right here. So much for theatrical release, right? But so here, my red grid is rotated by quarter pi, and then I'm translating to the center of the screen. I'm rotating my green grid by quarter pi, right? Or we can just keep it on the previous values. Well, actually, let's keep it at the quarter pi. All right, so it doesn't look particularly pretty, but I hope that technically it explains how this whole thing functions. And then, so in the next video, I'm going to explain what are some of the options that you can explore with motion and rotation of actual shapes. So if you find an interesting way of dealing with those grids and try to like maybe increase or decrease the angles or rotate them in different directions, have them intersect and move around each other, that could be a very interesting thing to do, right? So right now they're very static. Even though I'm using the draw function, I'm not changing anything from frame to frame to frame, but maybe some motion would be good. We're going to explore motion in the next video, but see if you can try and play around with it yourself. All right. Hopefully you're going to enjoy it, and yeah, have fun with it.